start. Okay, we are recording. There's me. Good. So on Thursday, we talked about Phong shading. And we talked about these three different lighting effects: ambient, diffuse, and specular. And I presented this slide and the next slide that ambient has consistent lighting, diffuse has lighting that consistently goes to each viewer, and it has to do with the orientation of the triangle with respect to the light. And specular will send more light towards someone who's opposite the reflection vector, and the amount of light is proportional. It drops off with respect to how far away you are from that reflection vector. And so then here's the exact formula, is that the shading is the amount of ambient, a coefficient, plus some coefficient times what we calculate as the diffuse. So we had a formula in class on Thursday where we looked at the orientation of a facet and the orientation of the light, and then we asked the question, what is the angle between the normal of this facet and the light, so the angle between those two vectors. And then it was the dot product of those two, and that gave us a diffuse factor. For this formula, we would take that factor and multiply it by the coefficient, Kd. And with specular, we had something where it was, we would take it to an exponent. There also was another strength component, which is just directly rolled into Ks. And so, if you go back and look at how specular is calculated, there's a strength component, and that's just reflected in this Ks term. And so this is what we did, is we calculated these three types of lighting, and we just combined them in proportion with some coefficients. And so how do you do that in practice? You need to know some lighting parameters, you need to know the direction of the viewer, and you need to know the normal of the triangle. So this is the signature for calculating Phong shading for a function. And here are all the lighting parameters. And so it's what's the direction of the light. That's something that's in the slides. What's the direction of the light? These coefficients, and then the exponent for the specular term. And so this is code that is on the website and that you'll bring into your project. And you see there's a constructor, and the constructor will set all of these for project 1F. So what are you going to do for 1F? There's two goals. One is you add shading, and the other goal is that you make a movie. So of course we're doing building projects, so you're going to extend your project 1E code. And important thing, you're going to add to your code # define normals. So if you look at the 1E reader code, well, that is from fall of 16. Let's try again. If you look at the 1E reader code, then it's got this if-def normals in there. So the code that you put into your project 1E.cxx actually had some stuff that was if-defed out. And so now you're going to add # define normals, and that means this code is actually going to be part of, it will compile in, and you'll see what it does is it actually sets a normal for each vertex, right? And we didn't have that data member before, but we have it now. And so here's the slide saying you need to add that you're going to add this normals vector to your triangle. So before you had an X, a Y, a Z, and a color, and now you're going to have a normal. So there's this thing that has to happen in tandem. The minute you add # define normals right there, this code will get enabled. Well, it's going to cause a compile error unless you go and add this to be the data member of your triangle. Quentin, you're on camera, so you ready to be recorded?
Yeah. So,
she consented. Okay.
So if we just wanted flat triangles,
yeah,
we could just calculate it from the vertices, right?
So correct. So Yeah, so that's absolutely right. So like just putting it back in the context of Thursday's lecture, we had a flat shading versus smooth shading. And if we did flat shading, then we'd set the normal equal to the normal for that triangle.
Okay, so
And
these normals allow us to do the fancier.
these normals allow us to do the fancier. And so, we had a slide where we said, okay, here's a vertex, and this vertex has many incident triangles, and we'll calculate the normals of all those triangles, and then make the vertex of the normal be the average of those. And these normals that I'm handing to you are the average normals. So you should get smooth shading out of the box. Yeah, David?
So that would be something that would be calculated for all the triangles in workspace, and then we transform over to the best space, right?
You got it. And I actually have a little more in my notes here about that, but that's exactly right. I'm going to even make that a little more clear. So, so this is, I think this will demystify your question. So here's the project in a nutshell. You're going to add a method called calculate shading. And it's going to take, this signature, lighting parameters, view direction, normal, and you're going to calculate for a vertex the shading factor. And you remember in Thursday's lecture there was a slide on, okay, if I have this shading factor, how do I handle it? How do I modify the RGB, even if the shading factor is bigger than 1? So you're going to get a shading factor for each vertex, and you're going to treat it as a new field. And so for me, I actually made a new data member, which was my shading factor. And I just lerped it right alongside the colors and the Z. And so then I was getting for each fragment, each contribution to a pixel from the triangle, I was getting a shading factor that I was lerping, linear interpolation, as I did each scan line. And then I modified the RGB calculation to use shading. So in all, I only added about 30 lines of code to my project 1F. Now, that doesn't mean that I encourage you to do nothing for the next week and wait, right? Just get it done now. And of course, there's thinking. This calculate shading are 10 hard-earned lines of code because you're going to be implementing, all of those equations that we looked at in the previous lecture. I will put out data to debug. I actually have not put out the shading value for each pixel yet. And I just have this reminder here, we're going to do two-sided lighting for diffuse and one-sided lighting for specular. Here's the stuff that is out there. I have the correct answer for camera 000 or whatever, 1000. And then I have the per component value. So there's just ambient, there's just diffuse, and there is just specular. And I'm going to add some more stuff, which is the print statements that you guys are used to. First 10 triangles, what did I get out for my shading? I didn't say anything about movie encoders. So you're going to be modifying your program so it generates 1,000 images. And then you're going to take those 1,000 images and hand it to a program called a movie encoder. I expect most of you, and I have this in the prompt, will use FFmpeg. And this is just an experience that I think computer scientists should have, downloading software, figuring out how to use it, and getting the output. So it doesn't have to be FFmpeg. That's an easy one to use. It can be whatever you'd like. And so I think it's just a good experience to actually read a web page, read documentation, download it, install it, run it. And so that is part of the assignment here. Here's the PDF. Oh, here's the movie you're supposed to make. It's cool, right? Yeah.
Does VTK have anything built into making movies?
So not to my knowledge. So my game plan has always been to generate images and make a movie encoder. If it does, it's possible. And if you find it, you're welcome to use it, but not to my knowledge. Okay, and it looks like actually 34 of you have already viewed this. So this is the movie we're going to make. And here's the PDF of the instructions. So there's a lot of redundant stuff in here. It has all the same stuff about you need to add the pound sign to find normals and add a normal data member. And how do you index the normal data member? And the first one is the vertex ID, and the second one is the XYZ. And again, I added this double shading data member to a triangle. You need to download the file. It says it's called shading.cxx. Is that really its name? It is shading.cxx. And so this is what we already looked at with the lighting parameters and its value. Its values. You extend your code to do Phong shading. Again, two-sided lighting for diffuse, but one-sided for specular. And you'll compare with get camera. What do you upload when you're done? You upload your code. This time, I'd actually like a screenshot of differencer saying that it was less than 100 pixels. I also want to remind you all that the differencer that I put up on the web page at the beginning of the term wasn't perfect. I had modified it based on feedback from previous terms, and it would only do the first 20 pixels, and then it would stop reporting information. That sense has been fixed by one of you, and I've uploaded a new version. Please make sure you're using the new differencer. Download differencer again if you haven't downloaded it recently. Palmer?
But to clarify, certainly if the earlier version of the differencer tells you there's no pixels different,
You're good to go.
Okay.
You're good to go. But so the question was, if differencer says no difference, totally good, but that is not my expectation, right? So we've gotten to the point where we can no longer, Nara, Andrea, just wait a second. We've gotten to the point where we cannot beat the floating point precision issues, and it's my expectation that you will have different pixels. And so with 1E, the tolerance is up to 20 different. With 1F, it's up to 100 different pixels. Nara, is there a question?
I downloaded the differencer last night and it still stopped.
Okay, thanks for telling me that. Let's,
I mean, it's not that hard to change, you just change it.
well,
Yeah, if none different.
Only the first
It only report-
display.
yeah.
Yeah, no, I mean,
So it didn't do that before it got to 20 and effectively stopped. Now it will keep counting beyond 20, and the report will say 1,000 were different, but only the first 20 will print it out.
yeah, from what I understood of what you said,
Yeah.
I thought you meant the actual recording.
So I'm really glad you're asking the question because it sounds like I didn't say it right, and let's get it right. There's a line right here that says the number of different pixels is, and that's got to be less than 100. And it's only going to print the first 20, but it's going to count every pixel that's different. And so it's got to be, so this print statement, this print statement right here has to say the number of different pixels is some number less than 100. So even though it will only print out the first 20 that are different. Okay.
Can you do that for each image, for each of the 1,000 images?
No, just for the first one. Yeah. Yeah. I value your time not at all. Do this awful task. Okay. And then I'd like you to get me a text file containing a link to a movie you generate. It should be on a website or it could be on X. Do people know how to put something on X? Okay, so you have a public HTML directory and you can just do a secure copy to something to that directory and then it's on the internet. So if you don't know how to do that, ask a Piazza question. I do not want a Dropbox link. Dropbox seems to, when someone sends me a Dropbox link, then it becomes part of my quota, and I don't want all of your movies to be part of my quota. So I'd really like it to be posted to a website in some way. Again, incorrect images are likely to earn less than half credit. Here's what I did. Again, here's what I did. I added shading as a data member to the triangle, and then I just did lerping of my data member. I set them all to just be 0.5, and I just want to make sure that that worked. I could lerp correctly. I compiled it, I ran it, it looked right, and after I got all of my lerping working on a shading data member is when I actually implemented the shading equations. What I'm finding, and again, this is just with a portion of you, is that people want to implement everything. They want to do some thinking and almost make it like a notebook exercise and then implement it all, and then they can work to compile it, and then they run it, and it doesn't work, and they say, how do I debug? you should all aspire to write no more than 10 lines of code before you compile and run it, right? And so the strategy of I work it out in a notebook and then I'm going to implement it all, I don't think that that's an effective coding strategy. You want to put things into small parts and debug it. The movie encoder, FFmpeg, for the first time we have a grading rubric. So if you don't want to make a movie, cool. You can just do just the shading part and submit frame 0 and you'll get 5.5 points out of 8. The movie is worth 2.5 points out of 8. So you can get something that's more than half credit as long as you get the shading exactly right. You'll get 5.5 points and the movie is an extra 2.5 points. And again, I already said this, part of this assignment is learning a movie encoder, install software, learn to use it, etc. I think that's an invaluable skill. Okay, I'm getting ready to stop the movie. Is there any questions about 1F? Okay.